Guys, so we've all been to school, or we're all going to school, and our teacher has one point thrown at us this thing called the Pythagoras Theorem, and you just blindly plugged in your triangle sides, and you got something, and you're like, oh well, that works great, and you walked away with your math test. So the Pythagoras Theorem says if you have a square plus b square equals c square. So what does this mean? So say you have a right angle triangle. So right angle, side A squared plus side B squared will be side C squared. Now C squared is the hypotenuse, and the hypotenuse is always opposite the right angle. Likewise, the triangle, the smallest side is opposite the smallest angle. But whatever, that's not what this is about. So a squared plus b squared equals c squared. So how do you know this? Well, this is probably the easiest Pythagoras triplet ever. 3, 4, and 5. So 3 squared plus 4 squared equals 5 squared. And that's 9 plus 16, that's 25 equals 25. So it works, but what's the proof? So I'm going to draw another triangle. I'm going to draw a square this time, connecting. So you say something squared, you find the area of a square by squaring, putting air quotation marks, multiplying each side by another. Same thing twice. Let's say find the area of a square. Therefore, you're squaring it, making it a square. So I'm going to draw squares. This is terrible art, but you know what? This is not an art class. So 3, 4, and 5. So 3 squared equals 4 squared equals 3 squared plus 4 squared equals 5 squares. So basically the areas of these squares equal up. And if you can, and since the area of these two squares will always add up to the area of this square, then therefore you can just, that's how you basically find that's the math. When you want to find the hypotenuse of a triangle, you basically say, well, I know when you add up the square plus I know when you add up the area of this square plus the area of this square, then you always get the area of this square. The square root of 3 plus square root of 4, you're always going to get the area of the square root of 5, and that's how you solve it. So, practice problem. How does this work? Is this like one page? Oh, no. Well, whatever. Practice problem. I have an eraser. What do I erase though? Okay. So I'm going to put a divider here. Alright, practice problem number 1. Say you were given a triangle with this, wait, no. Much easier one. And then x. How do you solve this? Just pause the video and solve it. Alright, so here's how you solve it. 6 squared, the area of the square that'll be, if I drew a square over here, the area of the square plus the area of this square, so 6 squared plus 8 squared equals x squared. I don't know what the x is yet. So you have 36 plus 64 equals x squared. That's 100. And if 100 equals x squared, then we can just take the root of x squared. If you want to square root both sides, because root of x squared is x. Therefore, 10 equals x. So you're going to ask me, well, one sec. Let's just take this away for a sec. Let's just assume for 1 second that we're given the exact same problem, except we knew this was 10 and we knew this was 6, or we knew this was 6. Well, this time we do 6 squared, a square plus b square equals c square. So we gotta find b square. Here's do b square equals c square minus a square, because you're subtracting 6 squared is 36, and a square is 6. So for b square would be 100 minus 36, which is 64. And I'm not going to bother individually square rooting it this time. Therefore, b equals 8. So that's how I'd solve it backwards. So that was a proof on the Pythagoras theorem. Thank you guys for watching, and I will see you next time.